Let's talk about selecting a CPU for your computer system. There's always a wide variety of CPUs available to you, some better at graphics, number crunching, games, and so on. Two manufacturers dominate the CPU market. Intel has the largest market share. AMD is typically more cost-effective. Some CPUs contain a 32-bit architecture, some a 64-bit architecture. 64-bit processors can manage twice the data of a 32-bit processor. But 64-bit operating systems and 64-bit applications are required to take full advantage of their 64-bit architecture. 32-bit CPUs can recognize a maximum of 4 gigabytes of memory, while a 64-bit CPU will recognize up to 16 terabytes of memory. The instruction set specifies the kind of operations a CPU can perform. All 32-bit CPUs utilize the x86 instruction set. Intel's Itanium processor utilizes their IA64 set, while both AMD and Intel 64-bit CPUs use the x64 instruction set. As I said, while 32-bit applications and operating systems will run on 64-bit processors, you really need a 64-bit OS and applications to take full advantage of their capabilities. Therefore, cost becomes a factor in your decision. CPUs operate at a certain clock speed, measured in megahertz or gigahertz. Your motherboard must support not only the form factor or packaging of your CPU, but also its clock speed. Some CPUs support hyper-threading. Hyper-threading allows a single CPU or a single core to execute 2 instruction strings at the same time. Hyper-threading gives you about a 20% increase in performance. Hyper-threading is not to be confused with multi-core or multi-threading technology. Now for multi-core technologies. Most CPU dies in the past contained a single executing core or a single CPU. Now with multi-core CPU dies, you can purchase dual, triple, quad, or even 8-core CPU packaging. Operating systems and applications should be designed to take full advantage of multi-core technology. CPUs all use several levels of cache. Cache memory is fast, static memory. Originally, level 1 cache was located on the CPU, level 2 cache on the CPU die, and level 3 cache on the system board. With current CPU technology, all cache memory, level 1, 2, and 3, is located on the CPU. CPUs designed for portable PCs often can be throttled. Throttling allows a CPU to slow down or speed up as the need dictates, obviously increasing your battery life. Multi-core CPUs can even shut down entire processing cores to preserve power. Intel's Turbo Boost technology can allow a CPU to overclock as the need dictates. A word of warning now about overclocking. Overclocking, or pushing a CPU beyond its design specifications, can give you a marginal increase in performance, but can certainly decrease your CPU's life. Mobile CPUs work with a mobile chipset to conserve battery life. Let's discuss virtualization technology. Virtualization allows one computer, typically a high-end server, to perform multiple roles as if it were multiple servers. Envision a data center in which we have 4 servers, 4 physical platforms, each running an application. Maybe a database server, an application server, an email server, and a file server. Now, envision combining these services or these functions virtually onto one server platform. For all intents and purposes, these servers still exist, but they exist as virtual machines running under a single host OS on a single hardware platform. That's the concept of virtualization. One of the leaders in the virtualization market is VMware. Microsoft also has its own virtualization technology, which ships with Windows 2008. Let's look at some of your computer's internal architecture and discuss the front side bus, the North Bridge, and the South Bridge chipsets. Here we have a PGA, pin grid array, or possibly SPGA, staggered pin grid array, form factor CPU in his zero insertion force socket on a system board. The CPU resides on the system's front side bus, along with two other very important ICs, the North Bridge and the South Bridge chipset. These integrated circuits offload work from the CPU so it can handle key processing tasks. The North Bridge handles I/O to video and to memory, things that you want to happen very quickly on your system board. The South Bridge chip manages input and output to other internal and external expansion buses. The front side bus must clock with the speed of the CPU, and the faster, the better. Finally, let's discuss cooling. Heat is bad. An uncooled CPU will burn up in less than a minute. To cool your CPU, you'll need a heatsink, thermal paste, and a CPU fan. Let's summarize some CPU performance considerations. Clock speed is not the only measure of a CPU's performance. There are many other factors to take into consideration. Your motherboard must support your CPU of choice. Cache memory is important. The more the better. 64-bit and multi-core CPUs give better performance, but you'll want to purchase an appropriate operating system and applications to take advantage of their capabilities. Hyper-threading within a CPU can also boost its performance. And remember, overall system performance can also be improved with more memory, better cooling, and faster disks. Once you choose your CPU and system board, use proper cleaning and maintenance to keep your system working for years.